Okay. So, let us start with that new chapter, which is called analysis synthesis of pole 0 model. Basically, here we are dealing with that LPC analysis and LPC synthesis. Okay. Now, if you see in the speech production system, that Hz is my as per the discussion in their speech production system, Hz is a transfer function of the speech production system, which is nothing but a Gz Gödel transfer function multiplied by Vz vocal tract transfer function and radiation transfer function. Okay. So, this is the three transfer function which has to be multiplied to get the overall Hz. If you see in the figure, the overall Hz is this. Okay. So, if you see that how it is speech is model in digital domain, let us there is a impulse generator, then there is Gödel pulse modulator, Gödel transfer function, then there is a gain, speech gain, and if the speech is voiced, then it is connected to here. If it is unvoiced, it will be connected to here, which is a random noise generator. Okay. And that UGN pass through the vocal tract, find out the ULN, which is that output of the vocal tract, and to the lip radiation I get the speech. Okay. So, this is that vocal tract, you can say that LPC synthesis model, or I can say this is the vocal tract transfer function, how the vocal tract is can be digitized, or how the vocal tract can be implemented, that block diagram. Okay. So, Hz is nothing but a Gz, Vz and Rz. If you remember that what is the Gz? Gz is nothing but a 2 pole, I can vocal tract can be modeled as a 2 pole 1 minus E minus Ct z to the power minus 1 square. Okay. And Vz you have already said that if it is there is a n junction. So, there is a n by 2 k equal to 1 to n by 2, and this we have already derived, and radiation is nothing but a r 0 into 1 minus z to the power minus 1, one pole is derived that radiation pattern. Now, if I multiply this thing to get the Hz, if you see that Hz can be, if I say that e to the power minus Ct is equal to 1, c is the velocity of time, t is the time period of the Gödel pulse impulse, then I can get second order will be cancelled. So, I can see the total Hz is in the form of a all pole model. So, Hz I can express Hz is nothing but a all pole model 1 minus k equal to 1 to p a k z to the power minus k. So, this is the basis point why we do LPC analysis, linear predictive analysis for voice. Since vocal tract transfer function can be modelized or can be modeled using a all pole model, that is why that we have linear prediction can be possible in vocal tract or you can in the speech production systems. Now, if I go to the linear prediction systems, so I can say Hz, let us Hz is nothing but a output speech Sz divided by input is Uz. So, which can be modeled as A is the gain divided by 1 minus k equal to 1 to p a k z to the power minus k. P is the number of pole, p is the number of pole which we have already studied. Now, if it is that, then I can say the Sz is nothing but a Sz into 1 minus k equal to 1 to p a k z to the power minus k can be equal to a into Uz. Uz is the input impulse. Okay. So, or I can write Sz minus k equal to 1 to p a k z to the power minus k Sz equal to a into Ugz, which is the input of the vocal tract if it is voiced. So, if I see that the time domain function z domain it is like that. So, time domain Sn is nothing but Sn minus k equal to 1 to p a k S of n minus k is equal to a u g n. Now, if I consider that u g n is equal to 0, then I can say S n is nothing but a minus k equal to 1 to p a k s of n minus k is equal to 0. Or I can say S n can be roughly equal to k equal to 1 to p a k s of n minus k. Okay. Now, if it is that, then what I get from this equation? If I say that S n is nothing but a linear combination of previous sample n minus k with a multiplication factor a k, I can say that for k equal to 1. So, a 1 s n minus 1 plus a 2 s n minus 2 dot 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 a p into s n minus p. So, I can say that current speech sample can be a summation of previous multiplication summation of previous sample with a multiplication factor a. So, I can say if you see that this is a linear combination. So, I can say if suppose there is a speech sample is like this and those are the speech sample, this is the speech signal, those are the sample. Now, I can say that the sample number, this sample or this sample can be predicted or can be generated from the previous p number of sample. So, if I get the previous p number of sample and the value of a 1 to a p, then I can say I can generate the current signal which is S n, current sample S n. So, what is this? This is nothing but a linear prediction. So, why it is called linear prediction? Suppose there is a line. If this is the line, if I know this point and this point, I can say I can predict this point by linear combination of the previous point with a some coefficient factors. Okay. So, this is called linear prediction. So, I can say I can predict current sample from previous p number of sample with a corresponding factor a 1, a 2 and a p. Okay. So, what I get in here? So, if I know a 1, a 2, a p, those are the called coefficient. So, those are the linear prediction coefficient, I can say. Those are describing the properties of the speech signal and they will multiply with the previous sample which can be implemented easily by a delay. So, I can say this is nothing but a filter, those are the coefficient of the filter and those filter if I design a all pole filter using this coefficient and if I pass the previous p number of sample, then the present speech signal can be predicted. Okay. So, this is called linear prediction. So, there is a two problem. One is that I can generate S n or if I know a 1, a 2, a p, suppose I do not know a 1, a 2, a p, then I can say yes, if I know the current sample and previous p number of sample, then I am able to predict the value of a 1, a 2, a p for which my prediction is 100% correct. So, what is the prediction? So, I can say let us my prediction error is my predicted signal is x cap n, which is nothing but a k equal to 1 to p alpha k s of n minus k. Those are the predicted signal. Okay. So, I can say that those are the predicted signal previous p number of sample, from the previous p number of sample I know the alpha k, I predicted the current sample which is s cap n. Now, what is the prediction error? If I know the current sample, then S n minus predicted sample is my prediction error. So, S n minus S cap n is my prediction error. So, if I able to make that prediction error equal to 0 such that for the value of alpha value for whose value this error of the prediction is 0, this my estimated signal and my original signal difference is 0, then I can say those set of alpha represented this A1, A2 and AP. So, I can say if I know those set of alpha, I know the system, I can generate the system. So, there is two kind of things, one is called analysis, another is called synthesis. If I know A1, A2, AP and previous p number of sample, I can synthesize the current signal, or if I know the current signal and previous p number of sample, from the previous p number of sample, I can predict the set of value of A for which the error will be 0. So, one is called analysis, when I deriving the value of A1, A2 and AP is called LPC analysis, all-pole analysis. When I know the value generating the signal SN, this is called LPC synthesis. Okay. I synthesize the signal, let us describe in a block diagram in the error. So, I can say prediction error En is nothing but my current sample minus my estimated sample. Okay. If I write down that, so Sn is the current sample minus k equal to 1 to p alpha k s of n minus k. Okay. So, I can say if I in the z domain Ez is nothing but a Sz minus k equal to 1 to p alpha k z to the power minus k Sz. So, I can say Sz 1 minus k equal to 1 to p alpha k z to the power minus k. Let us I write alpha k into z to the power minus k, this portion is nothing but a Az. Okay. So, Az, so I can say this is my signal which is Sn. If I pass through this signal through a, let us I write down, this is called let us estimation Pz. I can get estimated signal which is S cap n. So, Sn previous samples are passed to a estimator which is nothing but a alpha k S n minus k, alpha k into z to the power minus k, Pz is equal to nothing but a alpha k. So, Pz is nothing but a k equal to 1 to p alpha k z to the power minus k. I get capital the estimated signal. Now, if I differentiate those two signal, I get the error signal which is En. Okay. Or I can system diagram, I can say from the beginning that S cap Sn minus S cap n is my the error. So, I can say that if I synthesize 1 by Az and if I pass the value of A u g n through this filter, I get signal speech signal Sn, where Az is nothing but a 1 minus k equal to 1 to p alpha k z to the power minus k. This we have done. Reversely, if I know Az, if I implement Az and pass the signal Sn, I can get En, because En is nothing but a Sz into Az, Sz into Az, Sz into Az, Sz into Az. So, I can say if I pass Sz Sn through a Az filter, I get En. So, I can say I can get the error signal if I implement Az and pass the present speech signal, I get the error signal. or which is nothing but a En is nothing but a AUGZ. If my estimation is very correct, or AUN I can say, if it is n, then I write AUGN. If my estimation is very correct, so that only I as an error. So, if I do this one, this is called analysis. If I do this one, this is called synthesis. If I pass AUGN and implement 1 by AZ, I can estimate SN. Okay. Now, what is the boil down the principle? Principle is that I have to either estimate the value of A1, A2 up to AP, or if I know A1, A2, AP, I have to pass the AUG with 1 minus AZ to get the signal synthesis. So, how do I estimate these values? If you see, I have only one equation. If you see that I have already, if you see this equation, I have only one equation where I can say Sn is equal to A1 S of n minus 1 plus A2 S of n minus 2 plus dot 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 plus AP S of n minus p. So, I can write Sn minus A1 S of n minus 1 plus A2 S of n minus 2 dot 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 AP S of n minus p is equal to 0. So, this is a single equation. How many unknown? A1, A2, A3 up to AP. So, in a pth order this equation, I get p number of unknown, but only single equation. So, if I have a 2 unknown, how many equation I require to derive that unknown? 2 equation. But here I see there is a p number of unknown, but only I have a single equation. The trick is that how do I find out a set of solution for which this is equal to 0. So, that means that if I know the previous n number of sample, some linear combination of those previous n number of sample will provide me the current sample. So, suppose I know previous 3 sample, I know some set of combination of this previous 3 sample will provide me the current sample. So, some set of previous sample with some multiplication, some kind of combination of this will provide me the current sample. Now, I have to find out which combination, which multiplication factor with sample number 1, which multiplication factor with sample number 2, which multiplication factor with sample number 3. So, there may be an infinite set of solution. I do not know A1, A2, A3 can be the set can be take the any value in infinite plane, infinite set. So, for any value I can get this current sample, but for particular some value the error will be 0. So, for an infinite set of solution I have to find out the optimum set of solution, or I can say find out the set of solution, or find out the set of the A1, A2, A3 value, AP value for which the error is 0. So, that means actually I am minimizing the error to predict the value of A1, A2, AP up to AP. So, that is why it is called linear prediction. I am predicting. So, I can say the current sample is predictable from set of previous sample with some linear combination. I can say if I know the current sample, if I know the previous p number of sample, I can find out for a value set of value of A1 AP, this current sample can be properly estimated or error will be 0. So, I have to minimize the error and find out the set of solution. So, I can say if my estimation of alpha k is, let us I estimate that alpha k. So, I can say En error for a m number of, let us there is a m number of signal, speech signal, I can get I can take n, I can take nth position, E n m is nothing but a S n m minus k equal to 1 to p alpha k s of m minus k s of m minus k. So, I can say okay, I have to estimate, I know the error. So, I have to find out the set of alpha k for which this error is minimum. So, what is the procedure to minimize the error? One of the procedure is mean square error minimization. So, I can say find out the mean square error. So, what is mean square error? E n is nothing but a m of E n m square, mean square. Okay. So, I can say E n is nothing but a m, what is error? S n m minus k equal to 1 to p alpha k s of m minus k whole square. Okay. So, that is the error. Now, what I have to know? I have to find out a set of value of alpha k for which this error is minimum, for which this error is minimum. How to minimize the error? Let us take the, you know the function minimization problem. So, minimize by setting what? I want to set d of E n by d alpha I is equal to 0. So, how to minimize? I have to minimize the function. So, the first order differentiation with respect to for which value with respect to which value I minimize it, value is alpha. So, let us del n by del E n by del alpha I equal to 0. Then I get the minimize the set of value of alpha k for which the function is minimum. So, I can say del E n by del alpha I is equal to what? Del of del alpha I minus infinity to infinity, m is minus infinity to infinity, s of n m minus k equal to 1 to p alpha k s of m minus k square. I just put the value of E n. Okay. So, if I take the derivative, what I will get? I will get, I am not deriving in paper. If you see the slides, if I take the derivative of this line derivative, I get 2 into minus infinity. So, a minus b whole square, okay, or a square. So, 2 into whole function again minus d by d alpha I k equal to 1 to p alpha k s n m minus k. Okay or not? Okay. So, if it is this, now if you see this d by del I del alpha I k equal to 1 to p alpha k s n m minus k, if it is this. So, this derivative only exists when alpha is equal, when this k is equal to I. If k equal to I, for that value this derivative exists, otherwise it is a constant. So, I can say this is nothing but a minus, so it is minus, so minus s n m minus I, otherwise it is 0. So, I can say the output of this one is nothing but a s of n m minus I. So, I can put that value in here. So, I can put 0 is equal to 2 of minus infinity to infinity s n m minus k equal to 1 to p alpha k s of n m minus k into minus s n m minus I. okay, Sn m minus I. So, if it is that, this equation, because del E n by del alpha I is equal to 0, I put that value equal to 0. So, 0 is equal to this. So, I can say this is equal to this. So, I can say this, there will be a bracket in here also, sorry, bracket in here. Okay. So, I can say phi, now if I just come out this side, S n, so minus infinity to infinity, okay, I will take another papers, let us take this one. So, I can say S n m minus I minus infinity to infinity into S n m is equal to k equal to 1 to p alpha k, k equal to minus infinity to infinity S n m minus I into S n m minus k. So, you just can do this. After I multiplying this this factor with this two term, then I can put it to this side. So, I can say minus infinity to infinity S n m minus I into S m, this negative I can take this side, equal to k equal to 1 to p minus infinity to infinity S n, this one, where I is equal to 1, I can vary from 1 to p, because I am taking the derivative of del alpha I, where I with respect to first factor alpha 1, with respect to second factor, respect to second factor up to alpha p. That is why the I will be 1 to p. So, now once this is equation like this is my equation, then I can say, I can write in matrix form phi n I k, I can write is equal to, let us write phi n I k is equal to m S n m minus I S n m minus k. If this is like this, then this is nothing but a phi n I is there, but k is 0. I is there, I can say k is 0 is equal to k equal to 1 to p alpha k phi n I k. Okay. So, after minimizing the function, error function, I get phi n I 0 is equal to k equal to p alpha k phi n I k. So, I can see there is a leading to a set of p equation in p unknown that can be solved in efficient manner. Now, if I say, if I write it in matrix form, so what I will write? This form. So, I can write this side. If I want to write this side, how do I write this side? This side I can write, let us this one phi I k, k equal to 1 to p and I also varies from 1 to p. So, I can say phi, let us 1 1, phi 1 2 dot 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 phi, I can say 1 p. Similarly, this side also phi 2 1, phi 2 2 dot 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 phi 2 p. I can write dot 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 phi p 1 phi p p. With multiply, this matrix has to be multiplied by alpha 1 alpha 2 dot 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 alpha p. This side I can write this matrix form is equal to k equal to 0. So, I can say phi 1 0 phi 2 0 dot 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 phi p 0. Now, if I able to solve this matrix, I can get the value of alpha 1, alpha 2 and alpha p. Once I get the value of alpha 1, alpha 2 and alpha p, for which my error is minimum, then I can set, okay, using this set of alpha value, I can correctly estimate the signal, the difference between the my present signal and the estimated signal, error will be minimum. So, if the error is minimum, that can I say this set of alpha value actually representing the production system or representing Hz for that time. Okay. Since the speech is time varying signal, let us I take the time instant, this instant I get some speech value. For those speech value, if I extract this alpha value, then I can say this alpha value can represent this Hz, or Hz can be implemented using this set of alpha value to generate the current signal. So, both way I can synthesize or I can estimate. So, once I estimate this alpha value, those set of alpha value represent that time the production system. So, those can be a parameters for those speech event. Those parameter is called LPC parameter, linear predictive coefficient parameter, alpha 1, alpha 2, alpha p are called the LPC coefficient. Now, how to estimate this alpha value? I have to solve this matrix. There may be a number of methods to solve this matrix. With the next class, we will discuss one by one methods. So, ultimately I have to solve this matrix. So, if I want to solve this matrix, there may be a number of method is available. So, using those method, how efficiently I can solve this matrix, so that I can estimate this value, and that is my target. So, first we will discuss about the autocorrelation method. So, there is three kinds of method: autocorrelation methods, matrix method, the covariance method, and another one is called the lattice filter methods. So, using those three methods, I will try to estimate the value of alpha 1, alpha 2 and alpha p. Okay? So, next class we will do that. Okay? Thank you.